Lesson 8 Solved Problems Part 1. Example 21. The vector AB has magnitude 10 units and it is inclined at 30 degrees to the x-axis. Express AB as a column vector. We have the plane S and Y axis. You have the vector AB, 10 units. We draw A towards the S axis. If you take B down, you have a right angled triangle. This is vector A. You have vector B. The angle that is inclined to the x-axis is 30 degrees. We need A and B in order to express AB as a column vector. From here, you have sine 30 degrees equal to opposite over hypotenuse in this form. Multiply through by 10 to clear fraction. The result is equal to 10 times 1 over 2. 1 over 2 is the special value for 30 degrees. You multiply and divide, you have 5. To get A, it must be cosine. So you have cos 30 degrees equal to adjacent A over hypotenuse 10 multiplied through by 10 to clear fraction. You have A equal to 10 cos 30 degrees, which is equal to 10 times root 3 over 2, and that is 5 root 3. Divide 10 by 2, you have 5. Vector AB as a column vector is this. You replace A with 5, B with 5 root 3. Example 22. The vector KL has magnitude 5 units and is inclined at 150 degrees to the x-axis. Express KL in the form A vector I plus B vector J. Solution. We wish to work with any of the special angles of 30 degrees, 45 degrees, or 60 degrees. For that reason, we have to convert this given angle to any of the special angles. 150 degrees is in the second quadrant, where sine is positive and cosine is negative, with formula 180 degrees minus theta. This is better understood under trigonometry. You can check the playlist College Trigonometry for more details. You equate the formula to the given angle. When you solve for theta, it is equal to 30 degrees. You have the diagram for the given information. You have it in the second quadrant because the given angle is in the second quadrant. In that quadrant, S is negative, hence you have minus A. B is positive because Y is positive in the second quadrant. Therefore, sine 30 degrees is equal to B over 5 multiply through by 5 to clear fraction, you have it in this form, and that is 5 times 1 over 2 equal to 2.5. Cos 30 degrees is equal to minus a over 5 multiplied through by 5 to clear fraction. Again, multiply through by minus 1 in order to have a to be positive, and you have it in this form. That minus 1 times 5, it becomes minus 5 times root 3 over 2, the value for cos 30 degrees. When you simplify, you have it in this form. In the required form, you simply replace a by this value times vector I, plus you replace b with 2.5 times vector j. Example 23. Let A, B, C be 3 non-collinear points. Find the resultant of the vectors, Roman figure 1, Roman figure 2. If D is a point coplanar with A, B, C such that vector AD is equal to 3 times vector AC minus 2 times vector AB. Prove that the points B, C, D are collinear. Solution. To obtain a resultant vector, you simply add the given vectors. So you have Roman figure 1, 2 times vector AB plus 2 times vector BC plus vector CA. If you add the first 2 vectors, you have 2 vector AC. The second component here is B, and the first is B also in the second vector. So when you add, you have the first and second point to be the results, plus vector CA. For us to add these 2 vectors, we need to interchange the position of vector CA to AC. The sign becomes negative. When you subtract, you have vector AC. Roman figure 2, you add the 2 vectors. When you open the bracket, you have it in this form. 5 is common, you factor it out. For us to add, we need to write minus vector AC to plus vector AC, so that the first point here will be C, since the second point here is C. So when you add, you have vector BA times 5. If B, C, D are collinear, we must be able to show that theta times B plus alpha times A plus beta times D is equal to 0, where B, C, and D are the position vectors of the points B, C, and D, and theta, alpha, and beta are constants such that theta plus alpha plus beta equal to 0. In the given question, vector AD is equal to this. We can write 3 times vector AC in this form, so that from here we can factor out 2, then we transfer this to the left, we have it in this form. If we interchange the position of minus vector AC, it becomes vector CA plus vector AD so that we can add and get this result. Here also, we interchange the position of this vector. It becomes this minus vector AB. If you factor out minus sign, you have it in this form. So we have vector CD equal to minus 2. If you add these two vectors, you have vector CB. If you transfer this to the left, you have this result, which can be written in this form. Now, vector CB simply means vector B minus C. Then 2 will multiply it. Then here also, you have D minus C equal to 0. If you open this bracket, you have it in this form. When you add like terms, precisely minus 2C minus C, you have 2B minus 3C plus D equal to 0. We are trying to rearrange this to give us this. When you compare what you have here with this, notice that this expression is equal to 0, theta is equal to 2, coefficient of B. Alpha is equal to minus 3, coefficient of C. Beta is equal to 1, coefficient of D. When you add both, you have 0. Because of this, the points B, C, and D are collinear. We have shown that. End of lesson 8. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared.